How do you really know the plastic in a water filter is safe? Today, we are going to dig deep into the technical validation of Nazava filters and look at the actual proof behind the promises.
So that's a pretty strong claim from the manufacturer. But in the world of technical validation, words are one thing, but data is everything. We need to see the numbers. So let's follow the evidence right from the very beginning.
All right, so where do you even start with something like this? Well, every product safety story begins with its core components. Before a single filter even gets made, you have to look at the raw plastic itself. This is the bedrock that all other safety claims are built on.
Now, the material at the heart of it all is a special kind of plastic called Polypropylene Random Copolymer, or PPR. Look, this isn't your everyday, run-of-the-mill plastic. Think of it more like the premium, VIP version, specifically engineered for things that demand absolute purity, like food containers or even medical gear.
And here's the thing, you don't have to take anyone's word for it. The material's own technical data sheet spells it out. It mentions excellent clarity, which is great for a water product, and, this is the big one, compliance with FDA regulation. That's a super strict US standard for anything that touches food. It means safety is literally built into its DNA from the get-go.
Okay, so having one certification is good, but what's really impressive is when you see multiple independent validations from all around the world. It's kind of like having several different experts all look at the same thing and all come to the same conclusion. That's exactly what we see next.
So this material doesn't just pass one test. It has what you could call a global passport for safety. It meets the American FDA standard, it meets Indonesia's national standard, and it meets the super tough requirements from the European Union. This creates a kind of triple lock on safety that's recognized across continents.
So, we've established the raw material is top-notch. But what happens when you melt it down and mold it into the final filter shape? Does it still hold up? Does that final product have the same level of safety, especially when you really push it to the limit? That right there is the million-dollar question.
To get a real, unbiased answer, you can't just have the company test it themselves. That's not how it works. You have to bring in an independent, third-party expert to really put it through its paces. And that's precisely what they did.
The filters were sent over to TÜV Nord. These guys are a huge name in independent testing. They're globally recognized as leaders in this field, so when they sign off on something, you know the results are credible, they're unbiased, they're basically the gold standard for this kind of work.
TÜV Nord ran what's called a migration test, which is pretty much the ultimate stress test for anything that touches your food or water. The idea is to soak the filter in different liquids, some that are acidic, some that are fatty, to see if any tiny microscopic plastic particles leach or, jump ship into the liquid. It's a worst-case scenario on purpose, designed to push the material to its absolute limit. So, the big moment. How did the filter actually do under all that intense pressure? Okay, let's get into the hard data, because this is where the story gets really, really compelling. First up, a test using a solution that mimics acidic things like fruit juice. And the result? A migration level of just 0.0063 milligrams per square centimeter. I mean, that is an incredibly small number. It's almost nothing. Next, they tried a solution that simulates something like dairy products. And wow, the result here was even more impressive, 0.0005. To put that in perspective, that's more than 10 times lower than the already tiny number we just saw from the acid test.
And what about for just plain old distilled water, the thing this filter is going to be dealing with every single day? Again, a minuscule 0.0007 milligrams. We're talking about a level here that is just barely even measurable.
Here it is. This is the official table right from the TÜV Nord report. Just look down that result column. It doesn't matter what they threw at it. Acid, different types of ethanol, water. The numbers are all consistently and unbelievably low. This just proves how incredibly stable the material is.
But this chart puts everything into perspective. See that tiny little sliver on the left? That is the highest result they got in any of the tests. And that towering bar on the right? That's the safety limit allowed by the European Union. So it's not just under the limit. It's over 1,500 times lower. That's not a safety margin, my friends. That's a safety canyon.
Okay, so we've followed the evidence from the raw material all the way through these intense worst-case scenario tests. So what does it all add up to? What's the real bottom line here?
Well, the path to proven safety is crystal clear. It's not based on one single claim, but on a whole chain of evidence.
It starts with a certified food-grade raw material from day one. It's then verified by an independent, third-party lab. It passes the most rigorous tests they can throw at it, and not just passes, but with these exceptionally high safety margins. And the whole thing is compliant with standards in the US, Indonesia, and Europe.
At the end of the day, this kind of multi-layered validation is about more than just ticking boxes on a checklist. It's about building a foundation of trust that's based on hard, verifiable evidence. It really makes you think. When a product's safety is proven at the material, national, and international level, what does that really mean for our confidence in the water we drink every single day?